All right. So, um, yeah, so today is Wednesday. So for Monday and Tuesday, we went over the Nikhil, if you want to talk about it.
Yeah. So basically on Monday, what we talked about is that we just talked about like what an SDK is, like how we use Android Studio, and we have a video about that, how to set it up. So if you haven't been here, you guys can just look at that and just follow that. We talked about what an op mode is, the basic Java variables, like basic Java, like variables, conditions, and methods. And there's a whole slideshow that's linked on the Camp Virtual Hub about that, and for everything else as well. So we also talked about like the autonomous op mode outline and how to write in op mode. And so learning all those things on Monday, if you want to go to Tuesdays, we implemented those while using the mechanism drive and encoders. So on Tuesday, what we talked about is like the concepts and the forces and the math of a mechanism drive. So like how the robot moves and strays. And Ishan went more in detail about the math, and we coded a set power method, and we're able to use that to drive mechanisms. And the
Mm-hmm.
next thing that we did on Tuesday is that with the encoders, we talked about how they work and how to use them, and we went a lot in detail about the encoder formula and the methods and how to strafe with encoders, and also just like explaining the general basis of why you want to use encoders and like the
Mm-hmm.
reasoning behind that, and not using time-based autonomous.
Yeah. So coming to Wednesday, if you guys noticed, we this camp has been pretty like autonomous oriented because like in our opinions, like for programming, the autonomous mode is probably where you can do the most advanced stuff. And when you get into higher competition, like worlds, for example, the top software teams and the top programming teams will spend most of their time working on the autonomous. And so far, we've gone over like movement and like how you can do all this stuff. But like one of the key parts of autonomous is usually going to be the detection, and you're always going to have to detect some sort of like object, since like I think relic recovery, you've always had to do some sort of color detection or image detection. And that's why today we're going to be going over the OpenCV library, and we'll be going more into that. And we're going to just be talking about how you can actually create a starter stack detector for your autonomous program. And you'll be able to use this after we finish writing it in your code for this year. So yeah, so we'll talk about like what OpenCV is, like the benefits, drawbacks to it, how to install the Easy OpenCV library, which is um, it's just a library for FTC. It's an OpenCV library, but it's kind of more oriented for FTC. We'll go into that as well. We'll talk about the structure of a pipeline, and we kind of talked about the op mode structure. Similarly, we'll be talking about the OpenCV structure. Then we'll go into like the variables, methods, same stuff as the SDK, but we'll be talking about the OpenCV portion of that. Then we'll talk about like how you can actually go about detection. So obviously, there's lots of different ways you can detect your starter stack. So some can be very simple, some can be very advanced, and then we'll finally actually write one together. All right, so let me get out of this mode. Let's go on to our OpenCV
Wait,
slides.
before we start that, okay, so yesterday we kind of forgot something that was pretty
Oh
important.
yeah.
So mechanism drive, we talked about the set power function, but how are we actually going to use that inside the teleop? Because I know that we're talking a lot about autonomous, but there's also some teleop advantages to that. So I'm just going to present really quick.
So just before we start OpenCV, we're just gonna like show you guys how you can implement the mechanism drive method that Ishan wrote, and how you can implement it into your teleop, and you can actually take your gamepad input and allow your robot to move in any direction you want.
And just to reiterate, this program was the set power method was written on Tuesday. So if you missed that or something, I would go back and look into that sometime after today's class. But this is fairly simple. So I just want to give you an overview of how this will look in the real, like if because like normally I would run it. I'm not it with my robot right now, so I'm just gonna give you an overview. So this is our teleop last year, which used the same code. So, so as you can see, you can like you don't you can normally like you would just strafe and go forward, but this you can see like it can do all kinds of complex motions. It can strafe and go diagonal and turn while moving and everything. And it's part of the reason why our teleop was a lot faster than some of the teams that did a regular strafe and forward movement. So I'm just going to X out of that now. So I'm going to show you how to actually do that now. So here's the set power method that we wrote yesterday. And then it's in the mechanism drive class still. So basically what you do is inside the loop, you first call set power. And then all you do is for the X input, you would put in the gamepad 1, which is already a variable created by first. You don't have to worry about all that. Dot. And then since I want the gamepad, okay, so let me so all right, so if this is my gamepad left stick, and then I have my gamepad right stick, I'm going to use this one for turning for now. So if I move this way, then it'll turn one way, and if I move it this way, it'll turn another way, right? And then for this, the left stick, I'm going to use it for movement. So if I go this way, then that would factor into my Y, and then this way would factor into my X. So if I go over here, then I would basically get my X and Y. So my X and my Y. And then I would plug it into the existing set power method that we already made. So to do that, let's just start off with movement. So as we said, the left stick X would plug into the X value, and then the gamepad 1.left stick Y would plug into the Y value. And then the rotation, we talked about how we want to use this gamepad for the rotation. So to do that, we're just going to measure the X value from the center. So if you're moving more this way, then you turn a certain way. And then if you go this way, you turn a certain way. And this would be considered a negative X value, and this would be considered a positive X value. So all we have to really do is pass in the gamepad 1.right stick X. So that's literally all you have to do to make the speedy teleop that most people have for their drivetrain.
Yeah, here, Ishan, can you just show this for one more second? Here, let me talk about something. So like, just what you're passing into this method is gamepad1.left stick X is going to be, so you're just accessing the variable left stick X, and that'll be a value that will be changed based on your X joystick input. So as the FTC SDK has already created this gamepad1 variable, or gamepad1 object, and then you're accessing the left stick X variable, and that variable changes based on your gamepad. So that's just a little information about that. Similarly to how you access like hardware map, like above hardware map.get, the hardware map itself is created by FTC, and that's the same thing for gamepad 1. And the left stick Y is going to be the Y it's going to be a variable, and that will be a value based on your joystick Y, like your left joystick Y, that'll change. And then your gamepad 1 right stick X is going to be again a variable that will be changed based on your input of your right joystick X value. So that's just a little information about that. Again, like we haven't taught too much of that just because it's going to be more advanced Java, and we can't teach that in 4 days, of course. So I recommend you guys just after this camp, just keep on learning Java. There's lots of resources. We can probably link a few, and you'll be able to understand this more object-oriented code much better. So
now I also want to add that I did gamepad 1.left stick Y, but I want to also go over like the buttons because it's very useful for the future. It'll be pretty quick, but say that you want to access the gamepad 1.A, like the button A on the controller, then you would just do if gamepad 1.left dot A, and that
can you make it equal to true? Like a equal to true instead of yeah,
I
just
will, bro. So this will return a true value if it's true, and then if it's false or if it's being pressed, then it'll return a true value. Okay, and then if it's being released, if it's not being pressed, then it will return a false value. It's a Boolean, like we talked about in the primitive types. It's a Boolean, and it will return a Boolean. So what what this is doing is this is the same thing as saying true, right? This having that is saying the same thing as true. So if I remove this, this is the same thing as what I had before. If gamepad.a is equal to true, I don't have to always put the equal true. Now, if I want to say equals to false, and I want to do something, so I'm saying right now I'm saying if it's released, then do something. Then I can do that, or I can just put a exclamation point here. It's just a cool Java thing. If you want, if it's more intuitive for you, then just put the equal false or equal true. But you don't really need to do that. I mean, so yeah, this is a good. This is how you would use those, and so yeah. And then if you want to use the triggers, then it would just be gamepad1 dot. And then you can literally just look through these. Like if you ever need something and you can't find it, you can like look through all the different things that they have. And then they also have like good documentation. So right now it's like fetching documentation, and it'll actually find the documentation. So let me go to let's say left trigger, right? It's fetching the documentation. Okay. What does that do? Okay, so it opened up this documentation. Oh wait, I just scrolled it. So if I do dot left stick x, then it gives me a little link here. And FTC was actually nice. They actually made documentation for us. So when you look at left stick Y, it creates this description. So it's a left analog stick vertical axis. That's what it's doing. That's what it's returning you. It's going to return you a double. And this is not the only place that you can look at that. You can also just search up gamepad, FTC. Okay. There's so many resources online.
and like documentation. We talked about this a little bit before, but it basically just explains to you all of the methods, variables, and classes that a certain API or SDK has in it. And since we're using the FTC SDK, this gives us all the information about the different methods that we can use that they give to us.
So here I have a gamepad in the documentation. It's alphabetically placed, so I found the gamepad one. And so here you can see all the different things that the gamepad has. So here you know that if I do gamepad.a, then I have a return a Boolean of if it's true or false. B is a Boolean. Let's see if there's any integers. Integer ID, I don't even know what that is, but it sounds cool. This is what documentation does, right? And then you have a trigger, left trigger. It returns a float. And by the way, just so that you know, it returns a float from 0 to 1. And then yeah, so this is the documentation. I'll just send it to you guys. And so yeah, that concludes my part of the thing. So if you guys, this code will be up on GitHub soon. So do you guys have any questions on this teleop stuff? I know that it was really fast. So no, okay. And I will give it to Nihar for his OpenCV discussion. All right.
All right. So, here, let me share my screen again. Let's get to that. All right, can all of you guys see my screen?
I can see it.
All right, cool. So, for detection, we will be going over OpenCV. So as you can see, this is just like an image right here of how your detector may look. This is not how ours will look. It'll be pretty similar, but yeah, so let's just start. So what is OpenCV? So OpenCV it stands for Open Source Computer Vision Library. and it basically allows you to create like pipelines and detectors. So you can just think of a pipeline as a detector in this case. So besides an FTC, it's commonly used in like Python, in the Python programming language, and you might hear it in terms of like machine learning. So for example, if someone wants to create a project to like detect or to see if a car collision might happen, or like if they want to see maybe if they want to create a detector to identify different types of clothing, they can use OpenCV to actually create that. And as you can see, like here are a couple images. So these two are Python machine learning things. So this image is able to like detect different like objects and people, as you can see. Here is something that's like detecting like cars and like trucks. So as you can see, it has like a rectangle around them to like identify it. And then here we actually have an image of a Skystone detector from last year. And this person was able to actually put a box around the actual image on the Skystone, as well as so they can identify if it's a Skystone first of all, or if it's a regular stone, and they're able to like box them, which is pretty cool. And just a bit about OpenCV and why we want to use it. So first of all, if you guys know, the FTC SDK or the project, it actually comes with sample code for detection, and the sample code it comes with is actually from Vuforia and TensorFlow. So the reason why we use OpenCV over Vuforia and TensorFlow is just because Vuforia and TensorFlow are the examples that they come with in the FTC SDK are machine learning models, and they're just extremely slow. So, Nikhil, do you want to talk about our experience with like Vuforia last year?
Yeah, so I was gonna say that. So basically, last year during Skystone, we started out using Euphoria, and we thought it worked because when you put up the phone very close to the Skystone, it is able to detect. But something we didn't realize was that like when we actually were like a couple feet back, it was very hard to detect, and it needed very bright light in order for it to work. Like we had to have a very bright lamp right next to the camera in the Skystone, and we realized that this wouldn't work during tournaments. And in our first tournament, when we tried it, it didn't work at all. And things like when we tried OpenCV, it was able to work from a very far distance. And just make sure you guys know like the benefits of different things, because we spent so much time working with Euphoria when in the end, even if we had the program working, like the machine learning wasn't able to help us
Yeah.
detect it correctly. So make sure you guys know like the benefits of that, and like we would suggest using OpenCV, and like many other teams do that as well. So like
Mm-hmm.
just know what like the outcome's going to be before you start programming it, because even if you do it correctly, it might not work.
Yeah. So like, if you guys don't know what a machine learning model is, like, I'm not gonna go too into it, but like, just think of it as a system that like compares a bunch of images to each other and like processes that data. So instead of like, so what we're going to do is we're going to do like some sort of color detection. And what this does, what Vuforia and TensorFlow are they basically do a bunch of like comparisons and a bunch of like equations and all that, and it basically just compares the images to each other. And it has this giant like data set of images that it will compare the actual image from your camera to, and that'll just, first of all, it takes a lot of time for it to process. um Machine learning isn't usually meant for just a single image, and it's not meant to run super fast. What we're trying to do is run really fast, because in autonomous, time is really valuable, as you guys may know, and you want to be able to do everything as fast as possible so you can score the most points. And this machine learning stuff just doesn't really work in our favor. Secondly, for the benefits of OpenCV, so we talked about like the drawbacks of Vuforia and TensorFlow. Let's talk about why OpenCV is actually good. And because so the way OpenCV works is it works by allowing you to create like pipelines and detectors. So it allows you to create it from scratch. So TensorFlow and Vuforia, the code is already given to you by FTC, and it's very difficult to actually customize that code. OpenCV allows you to, do whatever you want. So technically, you can create an OpenCV detector that's like as slow as Vuforia, but you can actually create one that's not as slow. But if you're using Vuforia and TensorFlow, you're not going to really be able to create anything better than what they already have, and it's just going to be, it's going to be too much extra work when you can actually just be working on OpenCV. So yeah, that's just the basics of it. So actually, before we install OpenCV, let's talk. I want to just ask you guys a question. So how do you think we can go about detecting the ring stack? Like, how do you think that you'll be able to do it? Oh, okay. So someone asked in a question, actually, Doge CV. So Doge CV was actually a library built on top of OpenCV for FTC use. And let's actually talk about what a library is really quickly, just so if you guys don't know what it is. So if you think about it in like a real world analogy, like say a construction worker is building a building. So the construction worker is not going to actually build the bricks, right? The construction worker is just going to place the bricks. So what we're doing is we're using like pre-existing code to create something off of that, right? So it's similar to like the real world. Like the construction worker is using the bricks; they're not actually making the bricks. Someone else is making the bricks for the construction worker to use. And the person that makes the bricks, they may not be actually digging the material to create the bricks. Someone else is going to do that for them. So it's just a giant chain of other people. You're using other people's code to do other stuff with that, and then you just keep it just goes along like that. So a library is basically just a uh, a repository of code that you're able to use and create something off of. So OpenCV is a repository of code that we can use to create a detector out of. So Doge CV was actually so Nikhil answered that, but Doge CV is basically just another library created off of the OpenCV library. And it was an easy way to create a detector. But the thing about it is that it was almost like pre-made code for you. And it would be good to use this year, but the problem is they actually stopped developing it. So the people that created Doge CV, they all graduated. So there wasn't any code for last year or this year. It was mostly a Rover Ruckus and Relic Recovery season code thing. So since it was built off of Easy OpenCV, which is we'll be talking about as well, we'll be just going back to that and creating our own detector off of that.
Yeah, and as Nihar was talking about how it's mostly pre-existing, doing something that like is on your own terms is much more easier because it's more compatible with the robot, and depending on like the range you want to see, like making your own detector is a much better option than using something pre-existing like Doge CV. But now that
Yeah.
it's not running anymore, we can just go to OpenCV.
Yeah, like I really recommend that you guys do something like OpenCV because it really helps you understand how the code works and you're able to customize it yourself. And say like if you're using the TensorFlow code and there's some error, like you didn't write the code to actually do the detection. Someone else did that, and that's really difficult to actually debug if any issues happen. So so going back to my question before, how how do you guys think that we can actually detect a ring stack? Like give me some examples of how you want to process that image, how you might want to, go about checking if it's a 1 stack, 0 stack, or 3 stack.
Color and height and maybe even shape, depending on how close you are.
Mm-hmm. Yep, that's a good idea. So you can use the color of the rings to, check if the stack height is a certain amount. Does anybody else have any ideas, maybe going into more specifics of how you can use that color that you've, gained?
The amount of orange that reflects off of them going back into the camera. If it's a lot of orange, then you can assume it's more rings.
Yeah, that's actually how we did it before. So, Nikhil and I created multiple detectors so far, and the first detector which we made and it actually worked pretty well was we first of all we cropped we cropped the actual image to the height of or to the area and height of 4 rings, and it would just be over the rings on your screen. And then what we would do is we would take the average of the orange color and we would say, okay, um so we would have these pre-existing variables which would have a certain amount of orange, or we would have like a value, right? And then we would say, okay, this stack, so after we've cropped the image, we would say, okay, so this stack is this amount of orange, and then we would compare that color to our pre-existing variables, and depending on that, if it's in a certain range, we would be able to figure out the starter stack height. And that's actually going to be very similar to how we're going to teach you guys how to do it today. So Luca said that you could apply grayscale and measure the lighter gray. So that's also another option you can do. The issue with that is grayscale is really, it's very, how do you say it? It's not very, like colors, there's lots of, there's a whole diversity of colors, right? Grayscale, it's only black, white, and maybe gray, like a range of gray. So you're not able to really differentiate between different values very well. And that's why, and grayscale also may change under different lighting conditions. And that's why we're going to actually be using YCBCR, and that's actually a different color space. So we can actually go into that. So actually, let's not go over installation right now. Let's just talk about how OpenCV works. So basically, so OpenCV allows you to use images, of course, and these images are actually in the form of matrices. So as you can see, this is what a matrix is. It's basically a grid. There's columns and rows, and each element will have a different value depending on the actual color, you know. So there's different color spaces you can use as well. So this, of course, is a grayscale. You can use RGB, which is red, green, blue. So let's actually look that up really quickly. So we can look up RGB, and let's just find an image. So RGB uses the red, green, blue values, and it basically says that each color is going to fall in a certain percentage of blue, green, and red. So it'll always be a percentage of these three colors. And the reason why we don't use RGB in this year's challenge is because under different lighting conditions, these RGB values actually will change a lot. And that's just how the nature of the color space works. So we will be actually using YCBCR. Oops. YCBCR. Okay, whatever. So this is how YCBCR looks. Let's just find some more images. So this is how a YCBCR looks. Each value is associated with a percentage of Y, CB, and CR. And so since this stack, or since the rings are actually this orangey yellow color, we're able to use this CB value to our advantage, because the CB value actually is very similar, or it's in the range of like yellow and orange. And yeah, so that's just the reason why we use that. So yeah, so let's just go over how we're actually going to create our detector. And the first thing we're going to do is we're going to take the image that the webcam or phone sees, and we're going to convert it from RGB to a YCBCR. So like we talked about before, we don't want to use RGB just because the values actually change over different lighting conditions. YCBCR doesn't actually really change much, and that's helpful for us because in different tournaments, your lighting conditions might be different, and it's just nice to have versatility. The next thing we're going to do is we will crop our areas for the image detection. So I'll actually show you guys on Paint in a little bit of like a visualization of how we'll do this. Next, we're going to extract the CB channel. So that's similarly to how I think Brady said it, where we'll take the amount of orange, and that's what we're doing here. We're going to take the orange out of the channel, or out of the out of the crop area. And then finally, we're going to store the average of the CB color. So we're going to store the average of the orange in the area, in the crop region. And then finally, we're going to compare the averages, so the averages of orange, to pre-existing variables to determine the height of the stack. So let me actually pull up a image of like a starter stack. Let's see if we can find one. Hold on. Hey, Nikhil, do you have an image of a starter stack that we can use?
Yeah, I think I can get one in a second. Let me look.
Yeah, let me just pull up Paint really quickly. Actually, I think I may have one. Really
Wait,
quick.
with like 4 or just?
It doesn't matter. Actually, I think I have one. Let me pull it up. Hold up. Let's see.
Yeah, I think didn't Ali send some or something?
Nah, hold on. Actually, he did, but I sent one to someone, so let me just find that really quickly.
Yeah, let me look.
Okay, I think I got it. All right, so let me copy this image and then paste it into here. So.
Okay.
So are you guys still all able to see my screen?
Yes.
All right,
Yeah,
cool.
it's there.
So let me just try to zoom in a little bit. Oh shoot, okay. So you'll be able to actually extract, or you'll be able to see, you'll be able to store your image, your frame, each loop in your program. So we'll be going over that, the OpenCV, the structure on how you can actually do this. But just think about it as you'll be able to store your image that your camera is seeing, each frame, in a variable. And using that variable, we'll be able to manipulate it each loop and do stuff to it to actually detect. And the first thing that I said is that we're going to do a crop of the stack. So let me actually get a let's get a rectangle. So how we're going to do this crop is we're going to do a crop over no, okay, yeah. So we're going to do a crop over this bottom ring. So this will turn into one image. This will turn into one mat or matrix. So we'll store this area in one matrix, and then that area in another matrix. So the reason why we're doing this is, if you think about it, there's only going to be 1 rings, 4 rings, or 0 rings. And how this detector will work is we'll say, okay, if there's any orange in this bottom box, then we know it's going to be 1 or 4. If there's orange in both boxes, then you know it's going to be 4. If there's orange in neither of these boxes, then you know it's going to be 0. So that's basically how you can figure that out. So hold on, my thing is kind of my screen is frozen. Okay, so yeah, so basically, just to reiterate, this whole frame is going to be stored in a variable. So a mat variable or an image, you can just think about it as an image variable. And then we're going to crop this whole entire image to these 2 areas, these 2 regions, and you're going to store that in another 2 variables. And we can call these 2 variables upper region or upper mat and lower mat. And then using that, we're going to extract the orange out of it. We're going to take the average of it, and then we'll be able to compare those average values to pre-existing values to determine what the starter stack height is. So let's actually go back and go over the installation of OpenCV. So I'm going to send this link in the chat so you guys are able to follow along. Please open your Android Studio up and have this page open as well, and we'll be able to proceed from there. So
If you guys have any problems with anything, just let me know and I can help you guys on the side if you have any problem with installation.
yep. So as you notice, the repository we're going to is actually called Easy OpenCV. And the reason, and so we have this team that actually was able to convert OpenCV code, since it's in Python, to work with the FTC SDK. And it's basically just, it's very, very, very similar to the real Python OpenCV, but it just has a couple things behind the scenes that allows us to work with the phone camera in FTC. So we're going to be going over the installation instructions, so how you can get this library into your project and actually access the different features of it, of course, to actually create your detector. So we're going to be using something called Gradle. And Nikio, do you want to explain what Gradle is?
Oh, Gradle, like for the Gradle scripts? Yeah, so
Yeah.
basically, in order for anything, if you're installing anything new that isn't part of the pre-existing Android Studio, is that you'll need to put them into the Gradle scripts, which basically, like, there's certain lines of code that you include in the Gradle scripts, which will basically get the project stuff from GitHub, and like with that, you'll be able to actually use the things you download. So things we're going to be doing today, basically in the Gradle scripts, is that you're going to link this GitHub. It's not actually like there's certain code that they already give in the README. So once you link that, it'll link their whole library into your like already pre-existing Android Studio. So with that, you'll be able to use everything in one instead of like having so much like different classes and code. You're muted if you're talking.
Oh yeah, oops. So it'll be able to like, basically what it does is it just allows you to like type in like lines of code, and it'll be able to, grab the repository from the GitHub, and it'll be able to get it installed into your program. So do most of you guys have your Android Studios open?
I do.
All right, anybody else?
Yep.
All right. So let's actually, I just put the GitHub page on my other monitor, and all right, so let me just open up Android Studio here, and let's just close these. And the first thing I want you guys to do is go to this page, which I linked in the comments or in the chat box, and this is just the OpenCV source code, and we'll be going through this and going through the installation. And you can find the installation instructions in the README file below. So what we'll do is we'll scroll all the way down to the install instructions. And first things first, we're going to open our SDK Android Studio project. So we have that opened up. Most of us do that, have that done. Then we'll open up the build.common.gradle file. So let's actually go to that right now. So build.common.gradle. So your file hierarchy should look like this on the sidebar. And what we'll do is we'll expand this Gradle scripts thing right here. And right here we see build.common.gradle. So let's open that up. So just double click on it. And yeah. So yeah, so basically it allows us to type in code and just makes it easier to, install stuff into our project. And going back to the GitHub install instructions, it says add JCenter to the repositories block at the bottom. So it should look like this. So the line we're adding is JCenter. So let's copy that. And let's find this repositories block. So it should be on line 98 around there if you don't have anything else installed. Okay, that's not there. It's closer to the bottom. So 105. So again, it's going to be after the closing curly brace of this flat dir thingy right there. So let's put that right there. Just make sure that's correct. So that should be how your repositories block looks now after you've added this JCenter line. So do most of you guys have that done yet?
Yeah.
All right, cool. So yeah, let's just move on to the next part. Open the build.gradle file in the team code module. So that's again in the Gradle scripts. So let's open that up. We are on the build.common.gradle. Now we have to open the build.gradle. And as you can see in these parentheses, really small right here, it says project FTC robot controller master. So that's just relating to certain parts of your code. So let's actually see what it said again. It said the team code module. So let's find the one that says team code. Build.gradle team code, FTC robot controller team code. So it should look like that. Now let's double click on that. And yeah, let's see what the line is. At the bottom, add this dependencies, and we'll copy that. And then, okay, so it already has this dependencies block right here. What we can do is just copy this line inside of the dependencies. So it says implementation org OpenFTC easy OpenCV version 1.4.1. So we'll just copy this line inside, and then we'll paste it after this annotation processor files line. So like that. That is what it should be. Does everybody have that down? So remember in your build.gradle team code file, and then you should have these two in your dependencies. This is the one that we pasted. So we're on step number 5 right now. All right, do most of you guys have this done yet?
I got it down.
All right, anybody else wanna? All right, cool. Let's move on. So open the build.common.gradle file and find the line min SDK version 19 and replace it with min SDK version 23. So when I remember installing it, I don't think the min SDK version was 19. It might have been like 22. So we may not have to actually change this line, but let's just see. So build.common.gradle, and then min SDK version, where is that? Okay, so as you can see, it already says min SDK version 23. So that means we don't have to change anything. So finally, what we can do is, if you notice, there was a thing at the top that said Gradle files have changed since the last project sync. A project sync may be necessary for the IDE to work properly, and what we're going to do is click sync now. So that will just sync all of the files up, and this will take a little bit. It should basically just download all of the files from the GitHub page.
And you want to make sure that you're in the right Gradle script, because there's a lot that are similar, like build common Gradle or just build Gradle. And there's actually 2 build Gradles, so you want to make sure that you're in the correct thing when you copy and paste it.
So as you can see, I have this little thing right here that says Gradle build. So that means it's working and downloading all the necessary code that you need. And that should be working for you guys too. Let us know if there's some error going on, and we'll be able to help you guys out. For me, I actually had to install Easy OpenCV quite a few times because I made mistakes while actually putting it in the Gradle script. So like I put it in like the wrong file or something, and I had to reinstall stuff. So just make sure you've done it right the first time. If not, then that's fine. But so we can fix it, help you guys fix it right away. But yeah, so this it's just installing right now for me. You should probably have a little, a little installation thingy like down here somewhere. And I think, yep, Gradle sync finished for me. So it looks like I won't get any errors when I write OpenCV code. So yeah, let's actually get started. It's done for me as well. All right, cool. Let's actually just wait a couple minutes. We'll wait till 2:25. Make sure everybody has gotten it installed properly. So like for our team, like we use quite a few different libraries for different things. Like, movement of a robot, we use like a library for that, and for different things. So our where is that? We have like quite a few different dependencies, like implementations here, and after a while, it just gets like really nice to have like to just be able to like Gradle sync it instead of like going to the GitHub, like doing all this, maybe downloading certain classes and all that stuff. Instead of going through all of that, if you're just able to type in a line of code, click sync, and it's downloading the code for you. So that's really helpful. All right, is everybody else good with the installation so far?
Yeah, I'm done.
All right. Anybody else? Okay, so let's just start actually going over the OpenCV format on how you write a detector. So this should, make everything I've talked about a little more clear. So first of all, if you guys know, or if you remember, with op mode, with the SDK op mode, you have these methods which you override, right? And it's being called by the FTC SDK. So anybody remember which, like one of the 2 methods that we override in the SDK for op mode? And if you want to say it.
Public voids init.
Yep, init. So the init method is one of the methods that we actually override, and it's being called by the SDK. So someone typed in the chat init start and loop. Yep, those are a couple of methods which you do override, which you can override. Start isn't required, but you can add code in the start method. But so for OpenCV, it works in a similar way where you're actually overriding a certain method and writing code inside of it. So there's a method called process frame, and process frame will actually the program itself, so since the SDK is going to be calling it itself, the process frame method actually takes in, or it requires a parameter, and that parameter is an image, and that image is going to be passed in through the SDK from your actual phone or webcam. And using that image, you can actually do different things using it. So that image will be your, it'll be your starter stack height, or whatever your webcam or phone cam is seeing. And in this process frame method, you're actually able to do your detection. So in that method, it'll be called throughout your loop. So that image will be updated. That image variable will be updated with the new image that the webcam or phone is seeing. And using that image, you'll be able to detect. So you'll do all your detection in the process frame method. So let's just go over a couple essential OpenCV data types. So again, these are not primitive data types, right? So these aren't given to you by Java. These data types are given to you by the OpenCV, right? And similarly to the SDK, we have like DC motor that's created by the SDK. We have what are some others made by the SDK? We have like servo, we have hardware map, gamepad, of course. So those are all created by the SDK. So OpenCV actually has some data types as well. So they have a mat. So a mat you can just think of as like an image or a matrix of colors. Then we have a rectangle, and if we want to actually draw on our viewport, or our so your viewport is basically just your phone, or so if you're on whatever it is, expansion hub, you have a phone on your robot, and that will be where you can see your view, and that's just your viewport. Control hub, I don't think you're able to actually see on your phone, but you might be able to you might be able to actually show what your camera is seeing on your driver station, but I'm not 100% sure. So yeah, so there's a rectangle data type, and you're able to create rectangles using that. So yeah, so we already went over this, which is like the mat visualization. So this is what the camera will see if it's looking at it through as a matrix. So here are a couple of important OpenCV methods. So as I talked about before, we have to do some sort of conversion, right? We have to convert the RGB to our YCBCR, and that is why we use the CVT color method. So a method again is a function. It does some it takes some sort of data and does something with it. And yeah, so we can actually pass in two different matrices or two different images, and it'll be able to, or not, you'll be able to, yeah, so it'll pass in one image, and it'll convert that image to whatever color space you want it to, and it'll put that data on another matrix image. So yeah, then we have this submat, and the submat method basically just crops a mat to a certain area. So it just creates a, let's just create a new okay, yeah, let me just show you guys how that might look. So say we have this, we have this image, this mat, and we want to crop it. So we'll create a submat, and that submat might be in this region. And when you're creating a submat, this will be one variable, this will be one matrix variable, and your submat will actually be another variable right there. So it's not really actually cropping the matrix, because you're not cropping it on the same image or on the same variable. You're cropping it on another variable. So your actual cropped data will be put on another variable. That's probably a better way to say it. So let me just try to make it easier for you guys. So we can just have variable 1, variable 1, and yeah, we can just, oops. I'm so bad at this, but okay, let me just find a, okay, 1. This is way too hard to do. Okay, whatever. So we have variable 1 and then variable 2. And you'll be able to see that in the code as well. Next, we have extract channel, and extract channel will basically, you know, it'll take the specific channel that we want to do and take the average of, and it'll put it on a different variable. And the next and final method that we will be using is called mean, and mean, of course, means average, and it'll average the it'll take the average of the color on a certain mat, and that mat will be, of course, our submat, our cropped region. So I think we've gone over everything pretty much. We did talk about creating the stack detector. So just going over that again, we'll first convert our image from an RGB to a YCBCR. And going more into the code, that YCBCR will actually be on a different variable. It'll be on the, we'll just create a variable called YCBCR image. Then we'll crop that YCBCR mat to the region that we talked about before. So let's go back to that other image. So it'll be cropped to 2 different regions, and those will be 2 different variables. Finally, we will extract the color, the CB channel, which will be, you know, yellow, orange, and then we'll store that average and then compare it to pre-existing variables. So let's actually start writing some code. So I actually have some code which I wrote before, and this will be pretty much what we'll be writing. And I'll just put this to the side so I can refer off of this to, you know, create this detector. So the first thing we're going to do is go to your team code package, similarly to before, and right click, create a new Java class, and we'll call this stack detector, and click enter. So yeah, I'm just going to wait for you guys to do that, and then we can move on. All right, so I'm assuming most of you guys have that finished already, and I'm not going to go over the basics of creating an op mode because we've already done that a couple of times. I think all of you guys have a pretty good idea of how we do this, but I'll just walk through it again. So first of all, we're going to extend the op mode, and then what we can do is hover over it and then implement the methods. So we have this init and loop. So let me actually do something. So public void init. So as you notice, I actually added this other method called init loop. And init loop is another method that you can use with op mode, and it'll basically run in a loop after you've clicked the init button. So the loop method runs in a loop after you've clicked the start button. The init method runs only once, so this will be executed only once after you've clicked the init button. And then this init loop will be executed multiple times in a loop when you've clicked the init button. And can any of you guys guess why we've added this init loop method?
Because we want the stack detector to be running while the robot is while we're in it.
Yes, that is correct. So, if you guys remembered me talking about before, as autonomous programmers, we really want to we value our time in our autonomous, right? Because we want everything to run as fast as possible, and we don't want to waste any time, so we can pump out as many movements as we can and actually score as many points as possible. And we could do our stack detection during our loop period. And that would mean we would have to wait a couple seconds for it to actually process and, give us our output so we can actually start moving. But what if we could do it during the init period before the program starts or before the 30-second period starts and already know where we want to go, or we already know what the stack height should be. And that is why we run it in a loop during our init period. So hopefully most of you guys have this method already. And remember, it's highlighted yellow. That means it's being called somewhere, and it's being called by the SDK. It's being called by FTC somewhere else. We don't have to call that ourselves. So the next thing we're going to do is starting from top to bottom, we want to actually create our variable to open up our phone. So let's create this. Let's not put that there. Let's put it before the init. So this will just happen when the program is generated. We will create this OpenCV phone cam variable, and just think about it like how we define our hardware variables when we're creating an autonomous op mode with our DC motors. We're going to import this phone cam, or we're going to create this phone cam variable, and that's going to be our hardware variable. So using this phone cam, we'll be able to start streaming our camera to our program. So after we've created this variable, let's create another variable called ring count. And ring count is going to, it's a static variable, so I don't really want to go into that. Okay, looks like there's an issue. Okay, hold on. Method does not. Static ring count, static double ring count, and set that equal to 0. So ring count is going to be basically our variable that will be updated with the stack height after we've done our detection. So currently it's set to 0. It's initialized to 0 because we don't really know anything about the stack height yet. So after the code will run to detect, this ring count variable will update, and it'll be updated to whatever stack height we've determined. So it could be 0, 1, or 4. Next, we will write the code to actually open our phone camera and start streaming our data, and that will happen during the init loop period. So let me actually copy this code, which I have, because it's quite a lot to write. So we'll just go step by step. So let's just alt enter that to import it, import the class, and import that. Right, perfect. So this is a variable which is holding the camera monitor view ID. I don't really know what it is. It's just some sort of information to tell about the camera, and you're going to use that to hardware map the phone cam variable. So if you remember, we have this variable above, which is a phone cam. It's set to null right now. That means it's, there's no information that's been given to it. Here we're going to be basically hardware mapping it, and similarly to how we do hardware map.get, we're going to create an instance of it using this OpenCV camera factory class, and yeah, do all of this stuff. So all it does is it just connects it up to the phone, or it connects up to your actual hardware. So just similarly to the hardware mapping, and you're able to specify which camera you want to use, or so you can use your front camera or back camera, and you can change that using this little thing right here. So we can change that to front if we want to do front. I want to use back because that's how ours works. You can change that to however you want to use that. And yeah, so I will actually paste this code in the chat so you'll be able to copy this. I personally don't recommend writing out all of this code if you're going to, create another detector. Just copy this type of code because it's not really something that you need to, you don't need to change too much with it. So it's fine to just copy and paste, and you know what it does, which it connects the phone cam variable up to your actual phone cam on your robot. And the first variable is going to be the hardware ID, or the camera monitor view ID, and that is actually used in the method that gets the instance of the phone. So do most of you guys have these 4 lines of code written? All right. So the next thing that we have to do is we will have to set our pipeline, and we won't do that yet because we currently don't have a pipeline in our program. And your pipeline is just going to be your actual detector. So let's just write the code to set it, but we are not going to actually pass in our pipeline. So how it looks is we do phone cam dot set pipeline, and we have to pass in a pipeline into these parentheses. And we don't have one written in yet, so I'm just going to put a comment in here and say pass pipeline, and we'll add that in after. So yeah. Finally, we will add this code, and let me just comment this full line out because I don't want to cause any errors in the program. And this code will start the OpenCV camera, so it'll start your phone camera up. So as we see, we're doing phone cam dot open camera device async, and it basically just it starts the camera up, and we have this onOpened method, which will be called by OpenCV. As we see this override, we know that it's being called because it has an override as well as a as well as a yellow highlight. And let's that class. As we see, phone cam dot start streaming. It will start streaming the actual camera, and we have a width and height 320 by 240 pixels, and that will be the actual that'll be on the viewport of your phone. So let me just paste this code in the chat as well. And let's actually delete these comments, which are signified by the slash and then in the asterisk. So you guys can keep this if you want to, but it's just there for you to understand what the code is doing. So Yeah, I actually recommend you just keep it and then you can delete it later. And let's do our commenting as usual. So just to keep it nice. So getting harder variables.
You didn't like copy the whole thing. There's like
Oh,
it's
did I
just like
not?
halfway through.
Oh,
Yeah.
oops. Oh yeah, my bad. And I already deleted the comments, so let me
Is that
let's see. Yeah, I didn't copy the whole thing. Let's get that. Shoot. So we have this. Oh, I can't paste all of the code because it's Google Meets.
Oh yeah, makes sense.
That sucks. Okay, here. Actually, I can just paste it on the document. On the
You just want to link the Hayspin onto it, so then they can just.
actually, yeah. I'll just make a new Hayspin. I don't want them to get all of the code that I
Yeah,
before.
yeah.
Let me just make a new Hayspin really quickly. Okay, just sit tight really quickly, and then I'll just copy the code and paste it on here.
Do you guys have any questions about any of this so far?
Yeah, this isn't the real meat of the detector so yet. This is just opening the camera
Yeah.
to get it working.
Yeah, I know. Seems pretty straightforward.
Yeah.
Yeah, and on Friday, what we're gonna do is that the encoder stuff we made, we're gonna be implementing both of these together. And you know how I talked about using the if statements to find out if it's 0, 1, or 4? That the code we do today will actually figure that out. Or you can go ahead.
Yeah, so I just pasted the code in the chat. This just, opens up the phone camera. It starts streaming. Start streaming the data. Let me just do our commenting again. Hardware variables and others variables. This hardware maps. This tells the to use. And then this starts stream. All right, so I'm assuming most of you guys have that done. And let's actually get started with the real code to actually detect our ring stack. So let's just create some space below this public void loop because we want to create. You're not allowed to create methods and other methods, and there's not really a point of creating it in this loop method, which we've done, or in this init loop. We'll create the method outside and class outside, and we will call it in the init loop. So we will do hold on, let me actually pull up the code quickly. So we will do class ring detecting pipeline extends OpenCV pipeline and 2 curly braces, and then we'll click enter. And if you guys notice, it's a very similar format to how we create a op mode. We do extends op mode. Here we are extending the OpenCV pipeline. So it's basically a template to create a pipeline or a detector, if you think about it like that. So do most of you guys have that done and have what we've done so far?
Oh yeah, I'm done.
Cool. All right. I'm assuming everybody else does as well. Just give it a couple more seconds. All right. So as you see there's a squiggly line right here. That means there's something wrong, but we can actually fix this by highlighting, click implement methods. And as we talked about before, the process frame method, click OK. And this is the process frame method. And this process frame method will be called by the SDK and FTC. It'll do it whenever we do this set pipeline. So now we're actually able to uncomment this line, phonecam.setPipeline, and we can do new ring detecting pipeline. And all this is doing is it's saying, okay, I want to set our pipeline, we're going to use a set pipeline method, and we're just going to be passing in our full pipeline class, and it'll be able to do its own stuff using that. It'll be able to call this method using this, set pipeline. All right. So as we see, it has an input or it has a parameter which we're passing in, and that is called mat input. So it's just a mat variable, and that variable will be our image that we are going to use. And that image, again, since we know that this method is being called by FTC, it will do the passing in itself. So it'll pass the data that it is streamed. It'll pass the image or frame through this method, and we'll be able to access it in here. So so the first thing that we want to do is we want to create a couple of variables. And the first one we'll do is called mat. So mat data type, and then we'll do y cbcr equals new mat. And since this is a variable that hasn't been or it's a data type that's not created by us, we have to do this new mat. And Nikhil, do you want to explain what a constructor, like this is a constructor where we do new and then mat and then parentheses. So Nikhil? Okay, if not, I can explain it. So basically, what we're doing is we're just constructing a new mat variable, and many of the other variables we use don't require a constructor, but for some reason, this variable has required a constructor with it. And what a constructor does is it allows you to actually pass in data into these parentheses, and that will do something, or that will basically just construct the variable based on a certain template. So for example, we might have a variable of the type house, and it might have a constructor, and what you can pass into that constructor is you can pass things like your rooms for your house. You can pass in the square footage of the house, and that will basically just construct your variable for you. So this one doesn't actually require any parameters, but we just do this new mat just because that's just they just have an empty constructor in their class, so we just have to do that and pass in nothing. Now what we'll do is we will do a conversion of this input. So we'll be able to use this input now. So let's do imageproc dot cvt color. So imageproc is a class, image processing class, that allows us to call this converting color method. And first of all, we see using this little box above, the first parameter is asking is mat src. So that's like the source. What is the image that we want to convert? So we will pass in input into that. So input. So that's just going to be our direct stream image from the phone. The next thing we will pass in, let's see if it comes up again, is the DST. So I think that just means destination, I'm assuming. So the destination will be this variable. So the YCBCR mat. So input, which is the thing we're converting. Then the second parameter is going to be the variable that we want the conversion to be on, so the destination. And then finally, we want to actually say, what do we want to convert? What type of conversion do we want to do? And since we know that, it's something that we already know is that the frame is going to be an RGB, and we want to convert it to YCBCR. As we see, it's a YCBCR mat. So, or we've called it YCBCR mat. Sorry, it's not already a YCBCR mat yet. And what we'll do is we'll do imageproc dot color underscore RGB to YCRCB. So then all this does is it will take in an input, output, find the output variable that we want to put it on, and then it will do the conversion, which is this is the conversion type that we want to do, RGB to YCBCR. And as you see, it actually says YCRCB, and I don't know why they have it in that order, but yeah, we'll just call it YCBCR. So the next thing we want to do is we can create a variable called mat output, and we can just create another mat. And so as you see, it says return null right now, and the return is going to be the frame or the image that shows up on your viewport. So you can actually technically change this. You can change the output on the viewport to anything you want. You can, or as we saw in this, you can have your output be an image with the areas of detection or the crop. So you can have it with these like rectangles on it, or you can just have it without the rectangles and just see what you've put in the chat. Or oops, sorry. Wait, did someone raise their hand? Do you have a question? I think we had someone raise their hand. You can just put it in the chat if you have a question. But okay, so what we were saying is we can actually change the output, and that is the return mat. So if we go here, it says return null, and let's just make it return the output, which is going to be another variable called output mat. And technically, we could just return input, and input would basically just be our stream that our camera is seeing. But I just want to be fancy and do output, and output will just basically be the same data that is on input currently. So let's do input dot copy to, and we'll copy it to output. Now output was currently empty. It was an empty mat, and now we're going to copy the data on input and put it on output and return that. And yeah, we'll just do that. So, does anybody have any questions so far about that? It might be a little confusing, but let me just comment it a little better. So let's just say this will be what we are showing on. So return output mat, that'll just be an image. Okay, so image conversion, and then copying data. Okay. So the next thing we want to do is we want to actually create 2 rectangles, and these rectangles will just be in the form of it'll be on a rectangle variable, and we're actually going to use a constructor here. And as I mentioned before with the house analogy, you want to give, like the house, you might want to construct it with a certain amount of rooms or a certain amount of square footage. With the rectangle, we want to give it the actual coordinates or the actual size, maybe the the area of the rectangle, where it's going to be on the screen, that type of stuff. So let's do rect. So data type, let's import the class rect. We'll just call it rect and equals new rect. And the first thing that we need to create a rectangle is going to be the it will be, wait, let me think about this. It will be the actual, it'll be the coordinate that it'll be the top left coordinate of where the rectangle will be. So we will do let's actually create 2 variables at the top, and we'll call it int rect 1 chord x, or we'll just call it rect1x equals, and we'll just set that to 0. You guys can change this later, just based on wherever you want your crop region to be. And then we'll just do int rect1y, make that 0. And then we will do int rect2x equals 0 and int rect2y equals 0. So we're going to create 2 rectangle variables. And what we can do is we can just pass in our variables into here. So rect1x, comma, so we have, yep, int x, y, width, and height. So this will just be the top left of the rectangle. And we will do the width, or we will do the rect y, so that'll be rect1y. And then the width, we can just do 119 pixels, and we'll make the height 69. So I've actually tested this out, and let me see if I have an image of it, of our detector, on how this actually might look. Let's see if I can find one. Honestly, it might be too far back. I'm trying to find it on Discord. Okay, found it actually. So let me copy this and paste it onto here. So this was actually how our detector looked, and it would again draw these 2 boxes, and this first one we're going to create is going to be so the first coordinate which we specified is going to be the top left of the box. And can I draw? No. It'll be that part of the box, and then the width, and then the height. So let's get back into Android Studio and continue. So this, or Android Studio is nice because it actually tells you like which actual parameters you're passing in. So I'm not sure why it didn't tell us right here. Maybe it's because we wrote variables in, but we have the x, y, width, and height just for the first rectangle. Now let's create another one, and that's going to be our bottom rectangle. Rect 2 equals new rect, and then we'll pass in rect 2x, rect 2y. We'll make the width 119, and then the height 20. So of course the height is not going to be as high because of course it's the smaller of the rectangle. Height is bigger on the top one, smaller on the bottom. And let's comment that out, and we'll say creating the first, creating the top. Moving on, and as you noticed, what did we do here? We created a rectangle, but we didn't actually put the rectangle anywhere. We didn't put it on our actual, viewport. All right. So we have someone raising their hand. Do you have a question? Please put it in the chat or turn on your microphone if you have a question. I think it was Skybang. Maybe that was a mistake again. Not sure. Yeah, we'll just move on. So we created 2 rectangles, but we didn't actually put them on a mat. We didn't put them on any image or any mat yet. So what we want to do is actually do that. So we'll do imgproc.rectangle. And the first parameter which it requires is going to be the it will be the place where you want to put it. It'll be the mat that you want to put it on, you want to put the rectangle on. And we will specify this mat as this will refer to the output mat variable, and let's just pass it in. So output, comma, see if it shows the other parameters, 0.1, 0.2. So we're actually going to pass in a rectangle instead of the points individually. Instead of constructing the actual rectangle in this method, we will actually just pass in our rectangle which we've made in a different variable. And that just makes it easier for me, and it also might make it easier for you guys to actually see what you're doing. So let's pass in the rectangle that we want to put on the screen. So let's do rect. We can just call this rect1 actually. This makes it.
You have a question in the comments.
Oh, we do. Oops. So for the first rect, is it correct? Rect1x and rect2y. Oh, did I make a mistake? I did make a mistake. That was actually my bad. It should be rect1y. That was my mistake there. We had Skybang correct me. So it should be rect1x, rect1y, rect2x, rect2y. So we have 2 variables for or 4 variables for 2 different x's and 2 different y's, depending on which rectangle we are placing them on. So, yep, that was my bad. So we have this going back to our actual method to, put the rectangle on the screen. We're passing in this rectangle 1, comma, let's see what the other thing is, a scalar color. So what we're going to do is we will pass in a RGB value, and what we can do is a scalar is basically a data type created by OpenCV, and it holds 3 different values, and since RGB is 3 different values as well, it makes it easy for us to just use a scalar value. So let's create a variable really quickly. Scalar. We'll just call this rectangle color. equals new scalar. So we have to do this constructor thing again, right? So we're gonna construct this scalar, and it requires 3 parameters. So we can just use this as a RGB value, like I said. So we can just do R for 0, 0, and then 255. So this is saying that we have a scalar with the values 0, 0, and 255. And yeah, it'll assume this as a RGB value. So let's just pass in rectangle color. Thickness, we can make thickness of this rectangle, we'll make that 2. And you can, of course, change these values to your likings. And we'll just create another rectangle because we've created the top one, rect1, which is the top rectangle. We have to actually show the bottom rectangle as well. So let's just copy this, paste that. We want it to be on the same mat, so it shows up both rectangles just like this. We want to use the rectangle 2. We want to use the rectangle color scalar, the same color. I think this will be a full blue color, just like this one. It's just going to be 255, the maximum blue you can do, and then thickness of 2. So drawing rectangles on screen. So as you guys may have noticed, we didn't actually do any detection yet. So I know we've done all of this. This is just visual stuff. This is not actually manipulating the mats, so, or the images. So now what we're going to do is we're going to actually get into the meat, and we're going to actually do our crop. So let's create 2 variables above here. And honestly, we should have probably created this these 3 variables as well up here, so they don't get created every single time this process frame function is ran through. So I think it's fine for these variables to not be up here, but let's just keep our mats all the way up here. And let's create a mat called upper crop equals new mat, and then mat lower crop equals new mat. So as I mentioned before, the way cropping works is you don't just crop the image itself or the variable itself. You have to crop it and then put it on a different variable. And those other variables we're going to use are upper crop and lower crop. So let's do that crop now. So let me just add a comment and say cropping the stacks. Cropping the image for stack height. So let's use the lower crop and let's set it equal to some data. And as we noticed, all of these mats have some sort of data on them. So it's some sort of version of the input mat, if you think about it. So input mat is going to be updated by the data from the camera. This YCBCR mat right here is going to be updated from the data from input. And the same thing goes. We're going to update this lower crop from the YCBCR mat, and we're going to crop this mat now that it has data from the input mat, which is finally from our camera. So what we do is we call this method called submat, and let's just do YCBCR dot submat. And as you see, it requires a rectangle in our method. So this submat is going to be called on the YCBCR variable. So it's going to just create a crop or a submat of this other variable right here, or this other image. So it's going to create a sub region of it. So let's call that method. And as you see, we can actually pass in the rectangle. So there's different things that you can pass in. You can pass in a row start, end, column start, column end, but those are just different ways to specify a region. So there's 4 different ways we can specify regions. We're going to just pass in a rectangle, and that rectangle is going to be the same rectangle that we passed in for that we drew on the screen, just to make it nice, because that, of course, we don't want the rectangle on the screen to be different from the actual region that we cropped. That'd just be useless. So let's pass in the rect1, and I think that should just be it. So now it's basically just cropped this YCBCR mat of this rect1 region, which we specified up here, and it's put it onto this lower crop mat. Let's do this with the same mat, or with this, let's just do the same thing and put it on the upper crop YCBCR.submat, and we'll do rect2. So I'll just say cropping YCBC, and then all right. So now that we've done this, I just want to ask a question. What do you guys think is the next thing that we have to do to actually detect? What we've done so far is cropped the region that we want to do something with, and we want to put it and we put it in a variable. So what do we want to do after we've cropped? Extract the channels and calculate media of color. So
Yeah, maybe use the means method.
yeah, so someone said extract the channels. Also, wait, so you just find these rectangle coordinates empirically in trial and error. So actually, the way I'm teaching you guys here is doing it empirically, so just trial and error. What you can do is, what we did is we took a percentage of the columns and rows of the matrix, and that's a more advanced way, but I don't want to make it too confusing to you guys and make these parameters like really huge. I can actually find the code for what we did. So let me just copy one of the lines and show you guys how it looked. So let's just paste that. So this was the code that we put in the first parameter of the rect x. So this x would just be the rows. So the maximum rows multiplied, or yeah, the rows multiplied by 0.18, and that would just be 0.18 is just a percentage, and it's just a percentage of our of our x coordinates, and that's just an easy way for me to visualize it. But honestly, I don't want to make it too confusing to you guys, which is why I just said you can, just empirically tune these values. So you can just change these variables. For width and height, that's pretty much just trial and error. Just you gotta figure out what it is. You only pretty much do it once, unless you're changing your actual field of view of your camera. So yeah, the answer to what I asked before was extracting the channels, as well as doing your average of your CB value or your orange value. So let's actually do that now. So we will use this function called core.extract channels. core.extract channel, and we will pass in, of course, our source. So the source is going to be the lower crop, and let's actually keep the destination our lower crop again. So it's going to use a lower crop, and it's going to put the extracting data on the lower crop again. So it's basically going to be an overridden variable. So as I mentioned before, variables can change throughout the program. So this variable right now is going to be a crop region now, or a crop region with the YCBCR color. Now it's going to be cropped with only a certain channel. So the next thing we're going to do is type in the channel of interest, which channel we're going to use, and we're going to use channel 2. So this is getting like really nitty gritty, but basically how channels work are channels work as like an array. So it's just a list of numbers, and these lists of numbers are indexed by 0. So the first number will be value 0, second number will be value 1, third number will be value 2. So the channels are Y, CB, CR, but since OpenCV works by doing Y, CR, CB, it would technically be 0, 1, 2. So CB is going to be 2, channel 2. And that's why we type in channel 2 right here. And then let's just do the same thing here, and we'll do that for the upper crop. And then upper crop, channel 2. So let's just comment that out. The orange color. All right. So now what we're going to do is we're going to take the average, and this average is actually going to be stored on a scalar instead of storing it in like an int or double. I'm not completely sure why, but we have to store it in a scalar, and then we have to take the first value of it. I'm not really sure what the other values are when you take an average, when you do like core.mean, which is the average function. I'm not really sure what the other values are. I always only use the val1 or val0, which is the first index. So let's create a variable called scalar, and we'll do lower average orange equals core dot mean, and we'll take that of the lower crop. This will just take the average, the raw average data. Cool. And then we'll do the same thing for the upper average orange. So by upper and lower, I just mean the crop region. So upper crop region, lower crop region. So now that we have that data, the raw data, because there's going to be 3 numbers, we have to take the first number, and that's going to be our final average data of the orange color, or the CB color. And let's do double final lower average, just do average, equals lower average orange dot val, and then we'll use these square brackets, and that just signifies it's an array of numbers, and we'll take 0. Double final upper average equals, and this final just means like our final value. That's why I just called it that. You can name it something else if you want to, and we'll just do upper average orange dot val and take the 0 of it again, which is the first value. So do we have any questions so far?
Not really.
So just remember, guys, if I'm typing like way too quickly, which I apologize for since we don't have too much time with this, this will be up on GitHub with all the commenting and everything. I just want, like, it's just helpful for you guys to really understand how this works. Like, that's why I'm trying to teach you guys how the code actually works. So then, like, writing it is like very simple to do. Like how I think about it is like the actual difficulty of writing FTC code, it's not actually writing it. It's not like typing it out. Like the hard part is like how you're gonna do it, and like how you have to think about your algorithm. And that algorithm is, once you know how to do the algorithm and you know which things to use, it's very simple to do. You know about this submat method now, and you know about this extract channel and mean variable now. You can do so much with this, so it's really helpful. All right, cool. Typing speed is actually understandable. That's good. So now that we've done this, this is going to be our final value of our average. So after all of this, let's find which step we're on. We've stored the average of the color now, and now what we want to do is compare the averages to pre-existing variables to determine the height of the stack. So we had this variable up here called ring count, and this is where it comes in play. We're going to actually change this ring count variable. This variable will change now that we've gotten this data to determine. So how do you think we can compare these values? What Java utility are we able to use? What can we do? What code do you think we'll type or write to figure this out? Anybody can unmute or type in the chat.
Conditionals, I mean, to establish the height based on the comparison of the values.
Yep, that's correct. 3D color distance. So I kind of see where you're going with that, but we're not using any distance. So you can create a detector that uses distance, but what we're going to do is we're just going to say if our final lower average value is in the range of 2 values, then we know that it's going to be this ring stack height. If we know that final upper average is in between these 2 values, then we know it's going to be this height. And the way that you figure out your values is, again, the bad part is that it's going to be through trial and error. And the good side is that you can use this thing called telemetry. And telemetry data is basically data that you can output on your phones. And you can output things like variable values. You can output things like you can just output anything. And the way that we figured out our ranges was that we actually we did a bunch of tests. So we had like we had our detector running. We outputted these 2 values, the final lower average and upper average, we outputted it on telemetry data and it showed up on our phone. So it told us what variable value these two were. And we were able to actually write them down on a piece of paper. And we just went through multiple different tests, and we were able to like figure out an average and then finally create a range of that. And then, just test after that just to make sure it's working. So I'll just quickly explain how you can do that. So you just have to do telemetry.add data. And this is just adding data. So the first thing it'll just be a caption. So you can just say lower average, comma, and then your actual variable name or object value. So we'll do final lower average. And since we're in op mode, we don't have to actually do telemetry.update. That's a linear op mode thing, I believe, that you need to add to make sure it's updating properly. So this will just output the final lower average value onto your phone, and you can kind of do testing through that. So let's just delete that line and say we have values that we already know, and we use a conditional like someone said, Luca said that. So we'll do if, actually I don't think it was Luca, but it's fine. So if lower crop, so if the value is greater than 15, so and is basically a logical operator, and it basically just means and if this condition is true. So this condition would be lower crop is greater than 15 and not lower crop, final lower average. That was a different variable which I had in my other program, but we're using lower average. If lower average is greater than 15 and lower average final lower average final lower average is less than 130. So if it's in between 15 and 130 and final upper average is less than 130, then we want to say that ring count is equal to 4. So I just want to say, like, if anybody has to leave right now, since it's past 3:30, you can leave if you need to go somewhere, but this will be getting over pretty soon, so I recommend you stay. So as we know, this if statement, if this is not the case, if this condition is not met, then we actually want to use something called an else. So else, if, so if, then else if, so a different condition, if this condition is not met, then what is another condition? And this other condition will be if final lower average is greater than 10 and final upper average is less than 15 and final lower average is greater than 10 and final upper average is greater than or is less than 15. Then if that is the case, then we want to say that the ring count is equal to 0. And as you can see, the ranges here are from 10 to 15, and that's just a really low orange value. Here, it's in between 15 and 130. So usually, in my experience, the value was around 80 average for CB. And that just depends on different factors, like how far your rings are in your view and all that stuff, and that should change. But this generally should be the range that you're using. Again, I said you can experiment with these ranges. So, and then we do an else. So the final case, we don't need an else if because it'll always fall in this range, or it'll always fall in this else block if these two conditions have not been met, and that would just be if the ring count is equal, or that would just be the ring. That just means that the ring count is equal to 1. So that is pretty much it for this detector. Let's just finally add a comment here and saying comparing average values. And now that this has been created, what we can do is we want to say, so like this value will be updated, right? This ring count will be updated now. And in the loop, we can say if ring count is equal to 1, then drive somewhere else. If ring count is equal to 4, then drive somewhere else, because of course you have to drive somewhere else depending on where your or depending on your ring stack height, you have to drop your wobbly goal in a different spot, and that would just be we'll just say drive somewhere else, and then else. So this else case just is, since we have done 1 and 4, this is just going to be the 0 case. So if the ring count is 0, else drive to a different spot. And that is pretty much the code to to detect your starter stack height. And if you ever are trying to analyze the code a little bit, of course, use my comments which I've written to kind of understand what's going on. And then we also have these slides where we kind of outline the steps to to do this detection. And yeah, so that's pretty much it. Remember, this will be up on the GitHub, so be looking out for that. Besides that, does anybody have any questions so far, or now that we've finished? All right, cool. Hopefully you guys understand this code. I'm not the best at explaining these like methods, just because it's a little confusing how you have to, like add an input and then it will do something with that input, put it on a different variable. That's just kind of how OpenCV works. But yeah. All right, cool guys. Just one last thing. If you guys are wondering how did I figure out what these methods do, and what we can use is, like Ishan mentioned before, is documentation. So OpenCV has documentation. We can just look up the OpenCV Java docs, and yeah, it has all of the methods and the classes. So we can see OpenCV core, and for example, we have this rect, right? Creating a rectangle requires a height, width, all that stuff. So yeah, pretty much it. Thank you guys for coming to this to today's camp. Remember, there's no meeting tomorrow because it's Thanksgiving. I'm hoping you guys have a good Thanksgiving with your family, and be sure to come on Friday if you guys can. And that's where we'll actually combine this into one program to start writing some autonomous code. So I
Cool.
was, yeah.
Thanks a lot for everything. Like, I really learned a lot. I think that is